Hello everybody, welcome. This is Sparks, and today by popular request I will be showing you how to build my rotten flesh power plant and basically explaining how it works as well. Very quick, for people who don't know what this is a vanilla realism sort of roleplay thing I've got in my survival let's play world, and it has a mains cable running around my base that powers all of my devices, and the mains cable knows how much power is in it, and the generator, this big thing over here, which is housed in my power plant, has got 8 furnaces inside, and my power plant burns rotten flesh. Yours could burn anything you like, and if it runs out of flesh, the power stops working. And it's got a smart system built in so that because each device which uses this mains cable will actually subtract some of the power from the cable. So if these are devices here, I can cause it to subtract power. You can see there's now no power at all in this redstone line. It actually, as you can see, added more power. So more furnaces are now running. So that's basically how it works. It's got this smart system which works out how much power it should be using. And if these farms stopped drawing power from the system, then it would reduce the amount of power running through our mains cable to conserve flesh. This actually takes a very small amount of resources. This is a rough estimate at the amount you need. It may be a couple of items off in some places. So 5 stacks of building blocks of your choice. I've color coded everything here. Take a good look at them, pause the video if you're planning to build this. It's not too expensive. The most expensive thing is probably the mains cable, because the longer that gets, the more power you need, and it takes a lot of comparators because it remembers how much signal is inside. So a lot of this is modular, and it just requires repeating, so it's not as scary as it looks, and we'll go over it step by step. I've color coded everything. There is a world download in the description, but even if you just want to download it, why not watch the video? It'll explain how it all works, and you might learn something. So I'll get started building this. Alright, let's get started. We're going to start with the actual furnaces, the actual dispensers which are burning our flesh, as it were. So we're going to go 2 blocks across, and then we're going to go 1 up, and then we're going to put a dispenser on top, or a dropper. You can use either. Droppers are cheaper because they don't need a bow. And then we're going to go across a few blocks, like this, and there's going to be 8 furnaces total, and each furnace, or dropper, will add 2 to the signal strength. So we're going to go 1, then a space, then 2, then a space, then 2, then a space, then 2, then a space, and then 1. And this is just to do with redstone signal strength length. It makes things a little bit neater when it comes to working out how much power we want turned on. And now we're going to create the bit of redstone which locks or unlocks or turns each furnace on or off. So we're just going to put a little bit of blocks down there. You can actually delete these blocks if you don't want them. And then we're going to put dust here, and then we're going to alternate. So repeater, dust, repeater, dust. And this is literally just to keep the signals separate. You can put dust on the end here again. Then we're going to put a cable, or a line of blocks, 1 out like this, just running alongside all of our units. And then we're going to put torches, like so. So you can hear the dispensers are clicking on. We're going to put a line of redstone over the top. And we're going to put 1 block here with a bit of dust on top. That'll come in handy later. So the idea here is that we now run a line of blocks level with the dispensers or droppers here. And this line is going to be responsible for spitting out the flesh, for burning the flesh. So if we power these, you'll hear they're not clicking, and the reason is because they're turned off. They're locked by these torches here, so they're not going to do anything when this pulses to try and burn the flesh. But say we wanted to turn one of these furnaces on, this torch would turn off, and now this dispenser is unpowered, and therefore when I pulse this, you can hear it clicking, but all the others are not going to be spitting out flesh because they're turned off, and they won't burn flesh if they're off. So that's a good start there. Next, we're going to work on the part which connects up to the signal strength calculator. Okay, so this is the first section. I'll explain how it works, and then I'll show you how to build it, and then I'll do the rest off camera because they're just repeated. So this bit here works out whether the generator is valid for giving us power. This output repeater here, if it's on, then we're going to get power from it. If not, then we don't. And there's two conditions. First of all, the furnace needs to be turned on. So if this torch is on, the furnace is off because it's locked, right? So, and the other thing is that this needs to have fuel in it. So at the moment it's off and it has no fuel, so the output is off. If we put fuel in here, this piston drops down, effectively completing this circuit. However, since there's no power, it's still off. Now, if this torch were to turn off, we get output power because the furnace is on and it contains fuel. If it runs out of fuel, the piston rises up again and the output becomes off again. So very, very simple to build. It is staggered to avoid it interfering with each other here because they're right next to each other. So where we're basically going repeater dust. So there's a repeater here, so we put dust here. And there's dust here, so we put a repeater here. Then we're going to go 2 blocks up, and we're going to put comparators, and these comparators are to measure the contents of the dropper to work out if there's fuel inside. Then we're going to have 2 blocks, and we can put a repeater here and some dust here. It's just alternating to stop the beams from crossing, and if you've ever watched Ghostbusters, you know that you should never cross the streams. Then we put 2 torches here, and then I'll just put these down. You can't place redstone on glass. That was a bit silly of me, really. And then we can alternate again. So dust, repeater, dust, repeater. Oh, what am I doing? Hang on. We need to put our pistons right here. So facing down like that. And I'm using green just to indicate that the block moves. And then alternate again. So there's a repeater here. So we put dust here. And dust there, so we put a repeater here. If I put 2 dust here, the signal wouldn't travel through, so they need to alternate. Perfect. Next, let's connect this up, and I'll just build the rest of these off camera. Okay, that's been repeated all the way down the line, and you can see that I've started on the next section. This is the bit that sends that tells our system whether or not we want it out, and we're going to put the power calculator at the top here. So, very simple to build. I will show you, first of all, how the power system is going to work. So, we're going to put a redstone torch here. This is going to be our power source. And as you know, or should know, redstone torches give off a signal strength of 15. So, we're going to run a line down here. We're going to use yellow for our power line to make it nice and clear. And we're going to put comparators in line with all of these dispensers, like this, and then a block in between them, like so. Now what this is going to do is it's going to run that signal strength of 15 all the way along here and preserve it. So we're going to have 15 signal strength coming out here as well, and then we're going to right click all of these so that the little torch turns on, and this sets them into addition mode or subtraction mode. So if a comparator points sideways into them, it subtracts this signal from this signal. So because this dispenser is currently off and out of fuel, this block has risen up. If we turned it on and gave it some fuel, let me get some flesh a second, let's do this properly. Rotten flesh, under food, should be under power. Right, this block drops down. And we're going to put 42 items in here. I use redstone. You can use whatever you like. 42 is just enough to give out a signal strength of 2. So if this furnace turns off, this block will rise, and it subtracts 2 from our total signal strength. So this is 15, and then we subtract 2, so this is now 13. And we're going to do this all the way along here with all of these. So it's literally just building this up. So I'll do 2 again on camera and then finish the rest. So I'm just copying what I did earlier. So we have blocks coming out like this. And this just gets the signal up without it interfering with its neighbours. Like so. Ignore that. And we also want an upwards facing sticky piston along here with our block on top. Like so. and then we put half slabs level with the top of the piston with either dust or repeater. Again, we need to alternate the two. I need a repeater. There we go. Just like that. And I'm just going to repeat that all the way along here now. Okay, that's been repeated nicely all along. You can see that they're all pointing in to the power line here, and since all of these contain 42 items, which is just enough to give out a signal strength of 2, they're all subtracting 2 from the total signal strength, with the exception of the last one. This last one you want to put just one item in. Oh, perfect. Let's clear that weather. Okay, so the last one we're going to just take away 1 signal strength so that things are balanced. So at the moment we are taking away all that power. That torch there is having all its power sucked out, and there's no power coming out at all. You can see that it's not powering this torch. I could put a lamp right here, and it would do nothing. And as soon as one of these pistons drop, we have power. So that's basically how this works. This is our signal strength calculator. Let's go on and start doing the part which turns farms on and off, which goes just over here. Now, let's see. We're going to put a comparator facing in on the end of the cable here. And this is all about signal strength, so it has to be very carefully done so that the signal strength is exactly right, which is why this comparator runs here and why these torches have a gap every third block. It's just the way that the signal strength increases. And we're going to be using droppers with items in to calculate the signal strength. So we've got our comparator here, and we're going to put some dust here, and we are going to put 4 like this, and I struggle to remember this bit. 2 facing in opposite directions here, join them up like this, and then we put a block here, and then a dropper here, and a dropper facing in the opposite direction. So these droppers are facing each other, which means that if we put items in and power this, it'll put them in here, and if we power this one, it'll put items in here. And this one here is going to be responsible for our signal strength. So you can take some items, anything that doesn't stack. So I'm going to use wooden shovels. That's probably one of the cheapest things you can make. So we're going to take 8 of these. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. And we're going to put those 8 in this dropper. Now, since this dropper has 8 items in it, you can see that the signal strength reaches all the way to the end here, which means all of these generators are now turned on. So this is it outputting as much power as it can. You'll notice these blocks haven't dropped because there's no items, there's no fuel in the furnace. So we could put fuel in here, and it would cause those to drop, and then we get more signal strength coming out. So the idea here is that when we want to increase the amount of power, we can power this guy. I'm just putting these buttons here quickly. Power this one here, and you'll see that the signal strength drops. So every time we click that, nothing happens. Oh, right. It's because I was powering both dispensers. Let's put a block there. Okay, so every time I click this, one torch is going to turn on. So click it again, another torch turns on, another one. And this is basically how we calculate it. We can do the same thing with this one here. Every time we click that, it'll turn another torch off. So that's basically how that works. And this also connects quite nicely to our front readout, which starts here. There's 8 lamps, and the lamps will tell you about the signal strength. Okay, I started that one too far over. Let's ignore that. We're putting a block there. Oops. A block there. And then we're putting our 8 lamps here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and we're going to put a raised block here and a block on top here, and then some dust. And this block just stops that from doing that, because we want this piece of redstone dust to point straight at this block powering this first lamp. Then we're going to go 4 across here. So 1, 2, 3, 4. And after that, we've got that annoying gap, which you can see with these torches. So to keep things in line, we're going to go and put a block underneath this and a repeater here. And then we're going to join the two up like so. There we go. And then we're going to mirror that and go back up on this side. Is that a mirror? No. There we go, that's a mirror. And all the way up. So we're currently on half signal strength, and we can now really easily see that if I put those buttons back, pushing the button will add to this signal strength each time, and this one over here will reduce the signal strength. There's a slight bug with droppers. As you could see, the light was flashing but not going down, and that bug is generally caused by buttons. I think we're fine in terms of actually powering this with redstone, so don't worry about that too much. Okay, so these two droppers here are responsible firstly for turning generators on and off, and secondly for lighting these indicator lamps. Now, we're going to build the smart system next, which calculates whether it needs to turn generators on or off, which connects to these two. And since we want to do that, we should probably build an output cable. So we're going to build that here. It's very easy to make an output cable. The only thing to remember is that you want to make sure that there's never two pieces of dust next to each other, because that will degrade your redstone signal. So you can make it go down very easily like this. So you do dust, and then below that a repeater, a comparator, sorry. No repeaters, that will ruin everything. And then a block, and then dust. And then you can create your output power line like this. And what I did in my survival world was I went block, comparator, dust, block, comparator, dust. But then I realized that you can actually make this a little more efficient, and you can go block, comparator, block, dust, block, comparator, block, dust. And this is the cheapest way you can do to do this power cable. If, by the way, on a slight side note from the main tutorial, if you want to do lighting, where have the half slabs gone? If you want to run this power cable through the air and you want it to be a bit more sleek, you can do a sort of telegraph pole style thing. You can use half slabs, which take up less space, and then if you want to make it look nice and small, you can do comparator, dust, comparator, dust. This is more expensive, but it looks pretty good from below, very low profile. So if you want to bury it underground, it's a bit cheaper. Alright, I've set a very brief power cable. When you're building this in your survival world, you just want to make it the shortest loop possible, just to check it's working. You want your output to connect to your eventual input. And we're going to do the input now. Let's get a new color, just to make things nice and clear. This is our, I don't know, smart power thing. So we're going to go 9 blocks now. 1, 2, 3, 4, 5, 6, 7, 8, 9, which should bring you in line with just before the last furnace. And then we're going to go down in a step like that. Now we're going to build our first clock. This clock is going to basically periodically power this dropper here, and the clock will only be on if we want to turn off furnaces. As we know, every time we power this, items flow into this dropper and more furnaces turn off. So that's what this one's for. We're going to run our redstone wire along here, and our clock is going to go down here. This is a hopper clock. You're going to need some pistons and a redstone block, and a hopper and a comparator and dust. Yeah, we've got everything. So you're going to start by putting your block level with that dust. That's the start of the clock. Then you're going to put a hopper and another hopper, and these are going to point into each other, so that if you put an item inside, we're going to put in, I don't know, 13 redstone. They will flow into each other. And since we've got this redstone block here, it's only going to flow in this direction. If we put the block there and remove that block, then it'll flow in the other direction. And that's the basis of this clock. So we're going to put comparators here. Oops. And blocks and dust and pistons. Sticky piston, sticky piston. So this is now a functioning clock. The items flow from one to the other, and then once an item runs out, it switches in the opposite direction. So this basically is now pulsing and powering this dropper, which has nothing in it. But if it did have items in it, say this shovel, it will slowly send them back. Okay. Now, the reason we have a long clock here is to do with update. Think about it. You are trying to increase your signal strength, right? You want more generators turning on. So you increase your signal strength and you get more signal strength going out. And it takes quite a while to run along here because each of these comparators is one tick of delay. So we're effectively moving 3 meters per tick, which sounds very fast until you have a really long cable. So the longer this cable, the longer it takes for a change sent out to come back. So if you increase the signal strength and then increase it again before it's updated, you're going to have more signal than you want, and you try and reduce it again. You'll turn on the other clock and start reducing generators, and it will effectively never settle. So it needs a bit of calibration depending on the length of your cable, and we'll probably get into that in a later part of this video. Anyhow, let's move on with this. We want to turn this clock off if it's not needed. And that can be achieved, hasty jump cut as I look this up, by putting a block here with a bit of dust on it, then 3 blocks like this, and then a block against the output, the input comparator from your mains cable. So the mains cable needs to connect up exactly here. This is our smart detector. We're going to put 3 dust here, and a redstone torch is going to go right here. So this clock is now being powered on one side, which means that it'll stop pulsing, and then that's that section done. So if we have too much signal strength, let's put something strong here. If we have too much signal strength, that suggests the power's being wasted. So this dust here turns on, and the clock starts pulsing to reduce the amount of signal we're sending out. Once the signal drops below a relative threshold, it will be back here or here, and then this clock will turn off. Okay, so we have this clock here set up. This clock reduces the signal strength if the signal strength is too high. Let's set up the other one, which increases the signal strength if it's too low. So we're going to put a repeater here. So the idea is if this signal strength drops to 0, as is currently the case, then this repeater will turn off and it will allow this clock here to function. We're going to build exactly the same clock offset by 1. So put our comparators down and our pistons like so with a redstone block, and we're going to put our hoppers down facing into each other, and then I don't know, actually 12 is probably fine. There we go. So this clock is now going to keep pulsing every time the item runs through, and if we had 1 signal strength or more, this repeater will turn on and the clock will stop. So let's connect this up. We are now going to run very close to this cable, so we need to be careful what we do. We're going to put a block here and a repeater here, and this is why this block, this white block here, is here, because if it was lower, this repeater would power the wire. And then we are going to run our wire along the top here to the same length as that cable, and then to because if we put our cable here now, you can see that they're interfering. We've got the 2 cables interfering. We're just going to put blocks all the way along the top here, and that just keeps the 2 signal lines nice and separate. We're going to go over this piston now, and pistons have a horrible habit of being updated by a wire running over them. So we're going to put 4 half slabs, 1, 2, 3, 4, and that'll stop this redstone dust from ever interfering with that piston. And then we're just going to connect this up. So let's go and put a block here. This is our output, and then we're going to put a half slab here with some dust on top, and that's connected up. So now we should see that this is now actually functioning. You can see that it's not receiving enough power, and now it's receiving enough. So it turned on one furnace, which is this one here where the blocks dropped, which means we now have a signal strength of 2 going out. As you can see here, 1, 2. And because we've got enough signal, this repeater's turned on and the clock has stopped. If we had something drawing at that signal strength so that the return was 1, then this clock would turn on again, and we'll see that the generator slowly increases the amount of signal strength, the amount of furnaces being turned on. We've got 3 going now. And if that obstruction removes, we've now got too much signal coming back, so this torch turns off and this clock turns on, which will slowly reduce the signal, and we should now be running at a steady 1 generator. As long as this farm is on, you'll have to have 1 generator on so that it can work out whether it's getting enough power. So we're getting near done. The only thing we need to do now is, let's see, add a power switch. We need to add the flesh distribution system, which is that tall black thing, and the clock, which we use to spit the flesh out, and then we're done. Okay, let's build our flesh distribution system. You can use any system you like to fill these hoppers or droppers. You can, I don't know, use minecarts, something like that. This is just the system I've used. I found it worked very well for me. It's just a little bit expensive in terms of hoppers, yeah. So what we're going to do is we're going to do hopper 1. I want that facing up, just to be pretty. Hopper 2, hopper 3, hopper. So on top of our actual furnace down here, we're going to put 3 more dispensers and then a hopper on top. And we're going to do this for all 3 of them. This is just to give ourselves some clearance. We've got some redstone that needs to fit on top of this redstone, so we raise it up a little bit, and it actually acts as a backlog. If you're lucky enough to have that much flesh, it can start building up in this backlog space. So I'm just going to repeat this for all of these. Okay, that's been done. I'm going to use a nice dark color for this top, and we're going to put a line of blocks just underneath the top set of droppers. So this line is just going to run along here, and we're going to put comparators on them. And this is just a way of having less flesh stuck in your system, but evenly distributing it among all of them. Then we're going to put a block against the comparator, like this. And we're going to put a block directly above, like this. Oh, one too far. And then we're going to put redstone all along here. You can actually delete these 2 and these 2, but you need to leave the rest. I know there's nothing there, but if you remove these, I don't know why, but it doesn't work. If you get rid of that one, it doesn't work. If you get rid of that one, it doesn't work, and the same with these ones here. But you can leave those 2 out. Now we're going to go underneath, and we're going to put a second line right here with a line of 2 like this. So there's a 1 block high gap, and this is going to be part of the system. I don't really feel like explaining it. It's a whole thing unto itself, really. And then we're going to be basically using these repeaters and dust to power these hoppers. So we're going to go and put a line of redstone along here, and then we're going to put a bit of dust there. Then you can see that the next 2 are there. So we're going to do repeater dust. Again, we're just doing alternation to save on repeaters. And then the next 2 are here, so we can go repeater, dust, and then dust. Excellent. We're going to put a block here with a piece of dust on top. And then we're going to go and put 3 blocks here. Dust, repeater set to 3 ticks. This is one of the only repeaters that you need to adjust in the whole thing. And then we're going to run a line all the way along to the end here. We're going to, yeah, perfect. We need a repeater here set to 1 tick, just in line with that first gap we have. Dust running along here. And a torch right here. So this just keeps the bottom ones locked. And then finally we're going to put our actual hopper line on top. So you can put your first hopper facing down here, and then the rest face into each other along the top like so. Just going to go 1 out, And you can see they all run along like this until they reach the end. But these hoppers are going to pull the items down unless they're locked. And they'll be locked by this chain of redstone here. And then finally we're going to go 3 blocks across. 1, 2, 3. And then we're going to go down in a staircase to meet that other section, like that. Okay? So if we start putting blocks in here, if we start putting flesh into our system now, you will see that this is now filling up. And as it fills up, this comparator gives that signal strength. And once that reaches 42 or 41, this will switch to 2 signal strength and it'll lock itself. 42, there we go. So you can now see it's moved on and it's starting to fill the next one. This is going to happen all along, really. Let's put a couple in here to speed this process up a little bit. Alright, I stand corrected. All of these actually need to be repeaters. So you need to replace these dust with repeaters or everything will go all skew-iffy. But that's basically it. It's done now. We can put flesh in here. If I just grab a little from the foodstuffs section. And we should see that it slowly fills up. It's currently there. And then when it reaches the end, wait for it. There we go. It does a little flashy thing. And then it resets itself. And you can see it's now filling up again from the end. And that's there, there, there. And this basically spreads it every 5 flesh or so. It will split it down. So it'll do it again now. There you go. So the idea being in the end that you get an even amount in each of these. Now during my testing, they may have gotten a little bit out of sync, but generally this will work. So all we have left to do now is the timer, which causes this to pulse, and the power switch. And then we're done. Okay, so for this power system, we want to turn it off for a brief moment and then turn it back on again. So we're going to invert our signal first of all, so that they're usually on. And then we're going to put a bit of dust and a repeater, and set this repeater to 2 ticks, and place a piston facing up right here with a block on top. Let's get a green block. Let's remain consistent because it moves. And then we can go up a block here, put some dust, and then we're going to put our final clock on the end here, level with this redstone, like so. So you can see when I put this block here, it very briefly turns that repeater on, which creates our short pulse, and then the clock goes here. So we'll put our redstone there, and we will put our clock here. Let's see, we can put our comparators on the ends here. And we probably want to fill this clock fairly full. The more items you put in this hopper clock, the slower it will burn your flesh or other fuel material. So I personally have filled it up entirely. Let's put our pistons in. So we're going to put pretty much 5 stacks in. So it will very slowly pulse. So every 2 full rotations of items, it will be done. We could actually put a lot less in and watch it do its work a little faster for a moment. So in a moment it'll turn off like that. So the piston drops down, and then it goes back, and it'll basically be pulsing every now and again, and every second shift of the clock we'll get a short off pulse, and each time that happens a little bit of flesh will be distributed by the furnaces. Excellent, so that's our clock. Let's just make that nice and long again. Make sure you don't put more than 5 stacks of items in, otherwise it'll get stuck because they won't all be able to flow through anymore. So finally the power switch, which we can put over at the front here by our item panel. Okay, so you can put your power switch anywhere you like. You can use a lever if you like, or any kind of switch that takes your fancy. This is the one I did in my survival world. I went 2 blocks away from the indicator lights at head height, and I put my green on the right and the red on the left. And we're going to put a a dropper behind here and a second dropper behind facing the other direction. And then we're going to put a block with a comparator on top. You need a comparator. There we go. And then another block here with a torch on it. And then we put one item inside, just one. So what this does is if you press the green button, it turns the torch on because the item is over here, and therefore the comparator turns off and the torch turns on. If you press the red button, the torch turns off. So kind of a nice 2-button switch. You can use any switch you like. And then we're going to run our power line over here. Let's just turn our power supply on. There we go. So there's a couple of things that we need to connect this power line to. There's 3 things, in fact. The first one is the output. We want to turn the output off. The second one is this clock. We want to make sure that we're not spitting out flesh if the farm is off. And the third thing is we need to power this line right here, so that the farm thinks that it's getting lots of power back and starts shutting all the generators off, which means that when we turn it off, any furnaces that are on will slowly sink down to 0, which has quite a nice effect. So first of all, let's get our line set up over here. The simplest way to turn this all off is to just remove one of these blocks. So we're going to go 3 blocks up and then put a sticky piston facing down right here. And what this will do is I just temporarily put a block here to show you. When the farm is on, the piston will be down and the power will be going out. And when the farm is off, the block will be lifted up and the output will turn off because it's not able to have its signal sent anymore. Very simple. And then we just connect this up. So we can put a line along here. Hang on. Line along here. And our power line is down there, so we can go with the age-old system of using a half-slab staircase. Let's see, don't want to get in the way of anything. Let's put some scaffolding here. And that could actually go over one. Let's put it over one. This is just running wires, so you can run it how you like, really. This is just the way that I did it. So we're going to put half slabs like this in a staircase pattern. All of these are upside down half slabs so that redstone can stand on them. Let's run some redstone along here actually so we can check the signal strength and all that, and put a repeater here, and we can put our dust along here. So the dust is just going to climb its way up this staircase, and let's get rid of those. There we go. So it's now powering that piston. If your signal strength doesn't reach far enough, you can put a repeater up here to strengthen the signal. That's fine. And then you can get rid of your scaffolding. So that's the first part connected up. Very good. The next part is going to be inverted. We're going to turn this clock off. So you're going to go to this clock down here. This is your reference point, and you're going to put a block diagonally across like this. It should be underneath one of your hoppers. So we're going to put a torch directly under this hopper, and what this does is it locks it. So you can see these items are no longer flowing through. In fact, we have too many items in there. There we go. So this torch will stop the items flowing back that way. So eventually the clock will stop, and then put another torch underneath to invert it, and a repeater here to power the torch. The repeater is there so that this dust doesn't interfere with anything. And then we are going to invert this signal. So we can put a block here with a torch on it, and then it's just a matter of joining these 2 points up. So let's go along here. I shouldn't have made this floor out of glass. You can't put redstone on it, but that seems to line up okay. So we can take our power line along here, and now if we turn our farm off, which I can do quickly. Actually, hang on. Oh no, that's fine. That's fine. Sorry. So currently, let's just fly over here. Currently, that torch up there is off because the farm is on, and therefore this clock can run nicely. If we turn the plant off by pressing the red button, we'll now see that this piston has risen up so that the signal strength can't leave anymore, and this torch has turned on, locking this clock. The final thing that we need to connect up is this power supply here. See if you can get your redstone running along here. You need a repeater facing in here, and then a line running along here. I put a repeater here to stop that dust interfering with our line. You could use a comparator as well if you want, but repeaters are a bit cheaper. And that's basically it. So now the farm believes that it's getting lots of signal strength back, which means it'll slowly start turning these off. If we watch a moment, there we go. So eventually it'll power down to 0. If we wait a moment, hang on, I'll speed it up. Okay, here it comes, the last one. And there we go, the farm has officially turned off. If we press the green button, the farm will turn on, and you'll see that instantly we have a generator running, and everything's back to how it should be. And that's basically it. Your rotten power plant is built. It takes a surprisingly small amount of resources, considering, and it's not too laggy either. I mean, I run this on a server, and the server seems fine with it. So that's about it. The only thing really left to do is calibrate it. I'm trying to think of a good way of I haven't actually calibrated mine properly yet. I think it's running a little bit slower than it has to. Let me think about this a second and I'll come back to you. Alright, so by calibration what I mean is how quickly these clocks adjust the generator strength. You can't have this clock pulse on twice in the time it takes for the signal to make its way around your mains cable. And since the mains cable could be any length, depending on how you build it, I can't really tell you the exact number you need in there. So I've devised a little ping method, which is this thing over here. So what we have here is we've got a hopper with some items in and a chest. And we have the whole thing locked by this redstone block. And this redstone block is attached to a piston, which is currently being powered by this torch. So what's going to happen is, when we flick this lever, firstly, that torch is going to turn off and this redstone block is going to come back. And these items are going to start flowing into the chest. And secondly, this redstone line, without any repeaters on it, is going to run over here and send some power through our mains cable. So now, items are flowing down, there's power running through our cable, or starting to run through, and this piston is pulled back. As soon as the power reaches this end of the cable, it's going to power this piston. The piston's going to put the redstone block back, and the items are going to stop flowing down. So if we try this now, we should see this happening. There we go. So that's how long it takes it to flow through. We can see that 4 items made it through. However many items you have in this chest, double it. So we should be able to take our items out of here and put 8, sorry. There were 4 in the chest, so we put 8 items in, and that should be enough for it to correctly calibrate 4 items. Let me just show you what happens if we turn the farm on a second, because I had to turn it off for that test. Turn the farm on. I also need to turn my ping tester off. There we go. If there's only 1 item in there, or like 1 or 2, this happens. It starts getting very confused, and you can see that it just sort of keeps wobbling between states rather than settling on a number that it likes. And that's about it. We can remove our ping tester, which was just quickly being used to measure it, and if you change the length of your mains cable, you will need to remeasure that. I mean, you can put lots of items in and it will update slower and be safer. So if you see it sort of stuttering or wobbling between values, just add a few more items into these 2 clocks here and that should fix it. So, fairly complex project, but could be really awesome to play with. I'm certainly enjoying playing with it in my ALP multiplayer server world. I think people seem to be really excited by it, so I hope people enjoy this. If you modify it or include it in your world or anything, let me know. Send me screenshots. I'd love to see what people get up to with this and sort of how people modify the design and the idea. Thank you very much for watching, and thank you for requesting that I make this video. It's nice to see people interested. I will see you all next time. Bye-bye.